Hello everyone, in this video we'll be looking at science paper 1 2023 GCE, specifically question C1 and C2 from section C. So, question C1 reads, figure C1.1 shows a velocity time graph of a car of mass at 1200 kgs. Okay. So let me try to correct the data that I've been given. So my mass here, it is 1200 kgs. Okay. So the first question is question A, saying calculate the acceleration of the car in the first 2 seconds. So now when calculating the acceleration, what you need to know here is that you need to have the initial velocity and also the final velocity, and lastly the time. Okay, so the time here we have been given, which is 2 seconds. Then our initial velocity is going to be 0 meters per second. Then our final velocity is going to be 30 meters per second. So acceleration is equal to final velocity minus initial velocity divided by time. Okay, so we know that our final velocity here, it is 30. So I'm going to say 30 minus 0. Then the answer is going to be 30 divided by 2 seconds, then the answer is going to be 15. Now, since I know that acceleration is measured in meters per second squared, so I'm going to say meters per second squared. So that one was for question A. Question B reads, explain why the acceleration is 0 meters per second squared between 2 seconds and 4 seconds. Now, as you can see on the graph here, when the time is 2 seconds to 4 seconds, the car was moving with the constant speed. So I'm going to say because the car was moving with the constant speed, or let me say velocity, according to the information that I've been given here, I'm going to say the car was moving with the constant velocity. Okay, so that one is the correct answer for B. So question C is calculate the displacement of the car while its velocity was increasing. So, while the velocity was increasing, the time was 2 seconds, then the velocity was 30 seconds. Now, what you need to understand here is that displacement or distance is equal to the area under the curve. So now, as you can see on this diagram here, this one here, it is a triangle. So here I'm going to say area under the curve is equal to the distance or displacement. So area for the when finding the area of the triangle is like this. Area is equal to 1 over 2 breadth multiplied by height. Okay, so I'm going to say area is equal to 1 over 2 multiplied by breadth, which is this 2 here. Okay, then the height, it is 30. So the answer here is going to be 30 meters, since here we are calculating the displacement. Okay, so now here I was calculating the area, I was using A. So my final answer is going to be, therefore, a distance or displacement is equal to 30 meters. Okay, so that one was for the question C. Okay, question D reads, calculate the resultant force. Calculate the resultant force on this car during its acceleration. Okay, so now when calculating the force or the resultant force, since I know that force is equal to mass multiplied by acceleration, then the mass have been given, which is 1200 kgs. So I'm going to say force is equal to 1200 kgs multiplied by 15. Okay, multiplied by 15 meters per second squared. Okay, so my final answer here is going to be, let me try to multiply. So I'm saying 1200 multiplied by 15. Then my answer is going to be 18,000. Okay, so our final answer here is going to be 18,000 newtons. Since here we are calculating the force, so force should be in newtons. Okay. Then question E reads, distinguish between speed and the velocity. Okay, so there are there is a difference between speed and velocity. So now what you need to understand is that speed is a scalar quantity while velocity is a vector quantity. So here I'm saying speed is a scalar quantity while velocity is a vector quantity. Okay, the last one on this part, which is question F. Calculate the displacement of the car for the whole journey. So now, as you can see, this one here, the shape of the curve, this one here, it is called the trapezium. Okay, so now I was saying the area under the graph is equal to the distance or the displacement. So here I'm going to say, since this one here it is a trapezium, so I'm going to use the formula for finding the area of the trapezium, which is area of the trapezium is equal to 1 over 2, open bracket, a plus b multiplied by height. So now, my values for a and b should come from the sides which are parallel to each other. Okay, so now as you can see, when you move from 2 seconds to 4 seconds, this line here is parallel to the line when you move from the origin, which is O up to 8. So these two lines are parallel to each other. Okay, so now I'm going to say area is equal to 1 over 2. Then my A here is going to be 8 plus. So now for me to find the actual distance here, I'm going to say 4 minus 2. Then my answer is going to be 2. Then the height there we have 3. Let me say 30, not 3, but 30. Okay, so here I'm going to say the half of 30 here is going to be 15. Then area is equal to 8 plus 2. I'm going to get 10. 10 multiplied by 15, then the answer is going to be 150. So now, I was saying area is equal to distance or displacement. So my distance is going to be 150 meters. Okay, let's move on to the next one, which is C2. So C2 is saying a table C2.1 shows data collected from an experiment to determine the resistance of a conductor. So we have the voltage represented by V and also the current represented by capital letter A. So we have the voltage from 0 up to 80 and the current from 0 up to 12. So now the first question, which is our question A, is saying plot a graph of voltage which is V against current. So now when plotting the graph, the first thing here you need to start with the title. So our title here is going to be the graph of voltage, which is V against current, which is A. Okay, so I'm saying when drawing the graph, the first thing you need to start with the title. So I'm going to say the graph of voltage, which is V against current, which is A. Okay, then apart from that one, you need also to consider the numbers that have been given here. So now, according to the current, to the numbers, the coordinates in current, we have been given 0 up to 12, and then they are counting 0, 2, 4, 6, 8, 10, 12. So here my scale is going to be 2 centimeters is going to represent 2 units. Okay, so 2 centimeters is going to represent 2 units. Then as for the voltage should be in the y-axis. So now I'm coming from 0 up to 80. Okay, so now according to the coordinates that have been given on the voltage here, I'm going to say 2 centimeters is going to represent 10 units. Okay, 2 centimeters is going to represent 2 units. So for every 2 centimeters, I'm going to put 10 units. Okay, so our graph is going to look like this. Okay, so I hope you can see it clearly. So it will be like this. So the range is like this. On the voltage here, the voltage should be on the y-axis, then the current should be in the x-axis. Okay, so question B reads, using the graph to estimate the resistance when the current is 5 amps. So now when the current is 5 amps here, just go on the graph where you are going to find 5 amps. Okay, so in this case here I'm going to find the resistance when the current was 5 amps. Okay, so For me to find the resistor here, since I know that current is equal to voltage divided by resistance, so to make resistor the subject of the formula, I'm going to find that the resistor is equal to voltage divided by current. Okay, so now my current here it is 5 amps. Then my voltage here, I'm going to find it on the graph. Okay, so let me find it on the graph like this. So now our voltage is going to be 13. Now 13 is coming from here. So starting from 4 amps, since 2 centimeters is representing 2 units, so starting from 4, in 2 centimeters there are small boxes, there are 10 boxes, small 10 boxes. So starting from 4, count 5. So 4, 5, let me say 4, 4.1, 4.2, 4.3, 4.4, 4.5. So 4.5 is it will be E. Okay. So now on the 4.5 there, extend the line touching the curve. Okay. Then you are going to find that the voltage is going to be 13 volts. So 13 volts divided by 5 amps, the answer is going to be 2.6 ohms. So our resistor here is going to be 2.6 ohms. Okay. Then see, Roman numeral 1 is saying, does the conductor obey Ohm's law? Question mark. Now, as you can see, the way the curve is not straight. So I'm going to say it does not obey the Ohm's law. Okay. Roman numeral number 2 is saying justify your answer. So here I'm going to say because the curve is not straight. Okay. So here I'm saying the instrument can obey Ohm's law, or the conductor can only obey Ohm's law when the curve is straight. Now, if the curve is not straight, that conductor is not obeying Ohm's law, or that conductor can't obey Ohm's law. Okay, so to justify our answer here, I'm saying because the curve is not straight. Question D reads, what term is used to describe such type of conductor? So, the type of conductor which does not obey Ohm's law, we call them as non-ohmic conductors. So, I'm saying non-ohmic conductors. Then the last question, which is question E, give an example of a conductor that behaves like this. So, I'm going to say the bulb. The bulb does not obey Ohm's law. Okay, the bulb does not obey Ohm's law. Apart from the bulb, I can say the torch. So the torch does not obey Ohm's law. Okay, so that was the last one. Thanks for watching.